Hi everyone and welcome to the internet. What we're going to be doing in today's chemistry lesson is having a look at the process of distillation. So hopefully by the end of this lesson you're going to be able to describe what distillation is and explain how it actually works. To start us off, we've got 3 questions based around our previous lesson, so have a go at answering those 3 in your books for me. I'll give you a few minutes to have a go at those. Okay, let's check those answers then. So for question 1, hopefully you've got filtration for separating an insoluble solid from the liquid. Crystallization is number 2 for separating our dissolved solid. And then number 3, describing that process of crystallization. There's a total of 5 marks available for this one. So you get a mark if you've got using an evaporating dish for the solution. You get a mark if you've said you place the evaporating dish over a beaker of water. A mark if you've got that beaker of water over a Bunsen burner. Another mark if you've said you're going to heat the water to boiling. And then finally a mark for saying that once the crystals start to form, then turning off the Bunsen burner. So add it up, there's a total of 7 marks for your starter today. So add it up and write your score out of 7. What we're going to be doing in today's lesson then is having a look at a process called distillation. Now we're going to have a look at 2 different types of distillation today, and the first one is what we refer to as simple distillation. And the equipment we need to do this is on your screen there. So what I'd suggest you do is sketch that diagram and make sure you've got all those labels on there. So particularly important is the name of that tube that connects our round bottom flask end to the test tube. So that tube that we've labelled condenser, that is really important. So what we've actually got here then is the setup for simple distillation. So we start off with our solution going into the round bottom flask on the left hand side there. That round bottom flask is connected into our condenser by the connection there. We've got a thermometer at the top which is going to record the temperature of the vapour that comes out, and then it all goes into the test tube at the end. Now the way that this really works is we're relying on boiling points here. So as we actually heat up that round bottom flask, the chemical with the lower boiling point is going to turn to a vapour first, it rises up, and then it's going to go into that condenser. And the reason that condenser is so important is because if you look at the diagram, you can see that we've got cold water going in at the bottom, and then it's basically a tube within a tube. So along the very centre, we've got the tube that's going to allow the vapour to go down, and then around that we've got another tube which is going to have the water from our tap flowing along it. And the whole idea there is that it's going to cool down that vapour and cause it to condense. Then the liquid drips out into the test tube at the end. So I'm going to leave this up on the screen for about another 3 minutes. So draw that diagram for me with those labels. Obviously, if you think you're going to need longer than that, you can always just hit pause on the video. When it comes to thinking about when we're going to use simple distillation, then what we're going to do is we'll use this to separate a solvent from a solution. And the key thing about this is that the solvent must have a lower boiling point than the solute, so the solid that's dissolved in it. So write down those first two sentences and then see if you can have a go at answering the question at the bottom there. Explain why the solvent must have a lower boiling point than the solute. So I'm going to give you about 3 minutes to get those bits done. Let's check that answer then. Hopefully you pointed out that the solvent must have a lower boiling point than the solute because it has to turn to a vapour before the solute to actually allow this to separate them. If our solute had a lower boiling point than our solvent, then the solute would evaporate first and that wouldn't be any use for us. So what we need to do is have the distinct boiling points, and the solvent must have the lower boiling point to allow the separation technique to actually work. Then, as we said, once we've actually started heating, what we'll see is the solvent will become a gas, and then it's going to condense as it passes through that condenser, which then allows us to collect it at the other end. So make sure you've got those last two sentences written down about our process of simple distillation. I'm going to give you about a minute and a half to get that done. The second type of distillation that we can use to separate different mixtures of chemicals is a process called fractional distillation. Now, this is one of those processes that's going to come up in C2, so your first chemistry paper, and it can also come back up in C6, your second chemistry paper, because fractional distillation is a process that we're also going to use when it comes to separating out the different length hydrocarbon chains that we get in crude oil. And we're going to look at that in more detail when we go on to the unit C6, the final chemistry unit. Now, fractional distillation itself is capable of separating two or more substances from a mixture when they're both in the liquid state. So if we've just got a mixture of two liquids together, then this is the process that we would use to separate them. Key thing though is that each of those liquids must have a different boiling point. Because again, just like we saw previously, if they had the same boiling point, they wouldn't get separated. But different boiling points, one will evaporate before the other. And the key bit of this that's different is if you look at the diagram on the right, you can see that connected to our round bottom flask is this thing called a fractionating column. And there have been questions in the past where they've given you that diagram and asked you what piece X is, and it's been the fractionating column. So make sure you know the name fractionating column, make sure you know the condenser. So I would suggest again we do a sketch of that diagram. So what I'd like you to do is write down those 3 points on the left and then do a sketch of the diagram with those key parts of equipment labelled up. I'll give you another 3 minutes to get that done. So, see if you can have a go at this question then. Explain how fractional distillation is used to separate bioethanol from water. And I've given you a hint there that ethanol's boiling point is 78.4 degrees Celsius. So I'll give you a couple of minutes to have a go answering that question. Let's mark that answer then. 4 marks available for us here. First one is for pointing out that bioethanol will turn to vapour at 78.4 degrees Celsius. Give yourself a tick if you've got that somewhere in your answer. If you said that once it turns to vapour it rises up the fractionating column, give yourself a tick. If you said it condenses in the condenser, give yourself a tick for that one. And then your final mark is for pointing out that water will not turn to a vapour until it reaches 100 degrees Celsius. So do make sure you remember the fact that water boils at 100 degrees C, because again, that is a question I have seen on a GCSE paper in the past. So knowing some of those basic facts that water freezes at 0, boils at 100, those are some of the useful numbers you need to know. So if you didn't get that answer, I'd suggest you write down those 4 points. If you did obviously get some of them, give yourself a mark out of 4 for this. I'll leave this up for about another minute to give you a go to get any points written down you need. Final thing for today then are the plenary questions. So those of you with target grades up to a grade 5, the 2 columns on the left are your questions. Those of you with a target grade over a grade 5, it's the 2 columns on the right for you to answer. So I'm going to leave this up for about 4 minutes today, but as always, if you think you're going to need longer, then just hit pause on the video and take as long as you need to answer those properly in your books. As always, you can find the answers to the plenary over on my website, scienceright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.